In this problem, we're asked to find the reaction at C on this frame. So with a frame problem, the first thing we're going to do is decide what free body diagram to draw, whether we draw it of the entire frame or a specific portion of the frame. Since we know we need to find the reaction at C, I'm going to start by drawing a free body diagram of a member of the frame that contains C, and I'm going to draw a free body diagram of ABC, member ABC. So here's A, B, and C. And at A, I have a rocker, so I'm going to show an unknown force in the vertical direction, and I'll call that A sub y. At B, I have a pinned connection, so I'm going to show the x and y components of the reaction at B. And similar at C, going to show the two components of the reaction at C. So I look at this free body diagram. I'm working in 2D rigid body equilibrium. I have 5 unknowns: A sub y, B sub y, B sub x, C sub y, and C sub x. And I have 3 equations I can write. So I'm going to keep track of the unknowns and the equations that I have available to me up here. I'm going to say right now I have 5 unknowns, 3 equations. So with only 3 equations, I'm not going to get there if we have 5 unknowns. So we need to get the number of unknowns down, or get the number of equations up, until we have no more unknowns than we have equations available to us. So if I look at ABC, I notice that A sub y is the support reaction for the entire frame at A. So I should be able to solve for A sub y by looking at a free body diagram of the entire frame. And I'll do that. I won't draw another free body diagram just to save space here. I'm going to mark those unknowns right on the original figure here. So I have A sub y at the rocker, and then at E, that's a pinned connection, I'm going to show E sub x and E sub y. Now I'm just trying to find A sub y, so I'm going to sum moments about E. I'll do that under the original picture here. Sum of the moments about E equals 0, equals the moment of the 250 Newton force about point E, which is 250 times 6, minus the moment of A sub y about E, which is, it's going clockwise, so it's negative, therefore the minus sign, and that's going to be A sub y times the same 6 meters. So it turns out that A sub y equals 250 newtons. So I have A sub y, and I look at my free body diagram of ABC. Let me label that here, FBD of ABC. So I now have 4 unknowns and 3 equations. So I still have more unknowns than equations, and the reaction at B, the reaction at C are internal to the frame. So in order to generate more equations or have more equations available to me, I need to draw a free body diagram of another member of the frame. And you know which member, we have 2 other members here. Probably drawing either one, you could get to the point where you could solve the problem. I'm going to draw the free body diagram of BD and see where that goes. So I'm going to draw BD, FBD of BD. Okay, I'll draw it here. I'll draw it here. That is a horrible line. Try it again. Okay, where this is D, out here, B is about 1/3 of the way to D, and then I have the 250 Newton force acting downward. Okay, so let's put the unknowns on here. I have a pinned reaction at D, so I need to show the 2 components. So those are 2 new unknowns. If I look at the combination of ABC, the free body diagram of ABC and the free body diagram of BD. And then at B, this is where you have to be careful. The reaction at B is not going to add new unknowns because I've already accounted for it in the free body diagram of ABC. Notice here, I already have accounted for the reaction at B by drawing the components of B, the unknown components of B. So I'm not introducing new unknowns, but I need to be careful and draw these equal and opposite to what I drew on the free body diagram of ABC. So I need to show B sub y acting in this direction and B sub x acting in this direction. This is just Newton's third law, and this is how you work these frame and machine problems. But if you do not draw those in the equal, if you don't draw those in the opposite direction from what you assumed when you drew the first free body diagram, you're going to end up in trouble. So now let's count up the unknowns and equations. So I've added 2 more unknowns to my overall collection of free body diagrams here. I've added dy and dx, but again, bx and by shown on the free body diagram of BD are already accounted for in the free body diagram of ABC, so it does not increase my number of unknowns. So I now have, I had 4 unknowns, now I'm up to 6. But I've added 3 more equations with the second free body diagram. So now I have 6 unknowns, but I have 6 equations available to me. So I should be able to solve for all of these unknowns. I won't necessarily have to solve for all of them. I'm trying to get C sub y and C sub x. Okay, so I shouldn't need to draw any more free body diagrams. I just need to figure out the most efficient way to solve for C sub y and C sub x. Now let me put some, before I go any further, let me put the dimensions on here to complete my free body diagrams. This is 1.5 meters there, and from B to D, it's 3 meters. And back on my original free body diagram, I've got .5 meters, 1.5 meters, and then two meters and 2 meters in the vertical direction. Okay, so what I need to do here is solve for, I have 4 unknowns on my first free body diagram. I need to solve for either B sub y or B sub x in the second free body diagram, using the second free body diagram to decrease the number of unknowns in the first free body diagram down to 3, and then I should be able to solve for C sub y and C sub x. So in the second, for the second free body diagram here of BD, I'm going to solve for B sub y by summing moments about point D, and I have the moment of the 250 Newton force about D, which is going to be 250 times 4.5. And the way I showed B sub y here, and I have to be consistent now, that's B sub y is, the way it's drawn, is creating a positive moment about D of B sub y times 3. I solve for B sub y, and I get B sub y equals negative 375 pounds. So that negative sign tells me that I assumed the incorrect direction for B sub y, which is not a big deal. We don't know by looking at the frame necessarily what direction, what sense the unknowns are going to have. So on the second free body diagram, B sub y actually acts in the opposite direction of how I have it drawn, or it acts this way. And in the first free body diagram, it acts the opposite way of how I had it drawn. So it's actually acting that way. Okay. Now I know B sub y, so I'm going to check that one off on my original free body diagram. And now I've gone from 5 unknowns on that original free body diagram of ABC down to 3 unknowns, which are C sub y, C sub x, and B sub x. So now I can use the 3 equations associated with that free body diagram to solve for C sub y and C sub x. And I'll try and squeeze that in up here. So the first one I'm going to write is the sum of the forces in the y direction. And just to be complete here, I have regular frames of reference here, or reference axes. Draw this one down here. Okay. So in the y direction on my free body diagram of ABC, I have A sub y, which is acting upward at 250 pounds. I'm sorry, 250 newtons. B sub y, which has a magnitude of 375, but is acting downwards. And C sub y. Not sure if I gave the right number for B sub y. I meant to say 375 newtons acting downward, so that's why that minus sign is there in front of the 375. Now I can solve for C sub y. C sub y is 125 pounds, and I assumed its direction correctly. And to get C sub x, I've solved for C sub y. To solve for C sub x, if I sum forces in the x direction, B sub x is still unknown. So I'm going to have 2 unknowns in that equation. I would have to go back to the free body diagram of BD and solve for B sub x. But it looks like I can write another moment equation now and solve for C sub x directly. And unfortunately, I'm not going to have room over here where C sub y is. So now I'm going to say solve for C sub x and draw a big arrow over to some open area here. Okay. Let's use red. I'm going to solve for C sub x over here, where I have some space. Okay, so to solve for C sub x, I'm going to sum moments about B that is the most efficient place to sum moments because it eliminates B sub x from the moment equation, which is what I need to do. So I'm going to say the sum of the moments about B equals 0. And those moments are A sub y about B, which is going to be clockwise. So it's going to be a negative 250 times the 1.5 meters plus C sub y about B, and C sub y is 125 at 1.5 meters, and minus C sub x times 2. Sorry for squeezing that in there. And when I solve that for C sub x, I get 93.8 pounds. Okay. So the reaction at C has an x component of 93.8 pounds acting in the positive x direction and a y component of 125 pounds acting in the positive y direction.